Oh yeah, not sure what happened. My phone just stopped recording. So I was saying that the measurements of the coil are very, very important. That's the key rule. Everything you can figure that out with a measuring tape and a simple calculator, and you're good to go. I was gonna put the scope on it. So we'll check the light bulb, see what we got. Now you know your device is working properly when you see weird-looking trumpet waves. At least that's what they said in the book. Okay. Yeah, those are weird-looking trumpet waves. And the frequency's right at 3.250 megahertz. Yep. Looks right. Okay. We'll probe it on the capacitor. More of a trumpet wave. Right off the output. Yeah, more of a trumpet wave. So it looks like the device is operating correctly. I think what's happening is you're setting up a frequency, a very high rate of disturbance, a pulse, and once it's going, or when you're tuned into a certain high enough frequency, the system picks up more energy from. It could be solar radiation, stars, space, cosmic energy. It could be anything. Who knows? But anyway, the energy is there, and it seems to be usable, as you can see. About 12 watts. Very sensitive to tuning. Output varies. I'll plug in another bulb. It can run 120 volt bulbs. So yeah, I will plug in this bulb. And these bulbs get so bright they kind of hurt my eyes. They're LED bulbs. And I'll show it dimly running a incandescent bulb. Yeah, that gets very bright. That's lighting up most of my room. I mean, that's very decent illumination. It's very important to turn this energy to DC, store it in capacitors, and then run your load off of it that way. So now I will hook up a little, I think this is a 20 watt incandescent. I think I can get it to dimly glow red. So I'll hook that up. So I'm going to hook that up. He's dimly glowing red. That's an incandescent. These guys draw a lot of power. Yeah, that shouldn't even be possible for him to even glow. Come on, focus. See ya. Dimly glows. If I run it in pulses, I can get it brighter. So I got him glowing. I got those still giving off wireless power, no reduction. I'll go back to a regular LED light. This thing gets like mind-bogglingly bright. Yeah, see? Oh yeah, I was going to show you guys output power readings on this thing. So I'll get the meter. Stand the meter up. Oh, I'm working one-handed and it's kind of hard. Alright, here we go. Put the wires around this way. Here's the meter. Here's our output. connected. We got 337 volts. See if we can tune it a little more. Okay, 337 is the best we're gonna get. Gonna go milliamps. See what we got. 14 milliamps. So we got 14.30 milliamps. See if we can tune that better. 23, but what's our voltage now? 540. 543 volts? At how much? 23 milliamps. Holy crap, guys, that's a new record. I've never seen that before. Making me a little nervous now. Okay, yeah, I'm gonna run the light bulb again off that. That's the most power I've ever seen this thing kick out. I think that's almost... Well, I'm recording with my phone, but I'd use the calculator to check. I think that's under 20 watts. It's either 12 or 20. Yeah, that's bright. And our wireless power is still going, but the neon went out. That's interesting. That's a decent amount of juice. This is some form of tuned energy harvesting device. It needs an input, and your output is greater because once you're tuned into a specific frequency, you suck down more energy from some unknown source. Like I said, it could be coming from space. So 17 milliamps. See if I can get it back where it was. We had a surge in power not too long ago. 346. Oh, there it is. There it is. 516 volts at 13 milliamps. Tune it more. Okay. Huh, very picky. Very sensitive to tuning, very picky. There we go. If I just touch this, it'll probably go down. Yep. Very sensitive to tuning. I wonder if I can run a small motor. Hook it up to this motor. I'm not even sure if this motor works. Might be blown. This is a beefy motor. Ooh, we had something weird happen. We have no more output? That's weird. Sometimes the signal generator glitches out. You gotta restart it. Don't want channel 2 on. Channel 1. What was our frequency? Oh yeah, it was 3 million. Something weird's going on now. Did we break something? Oh, I disconnected down. Ouch, fuck. Jesus Christ. I just fried my finger. The weight of the motor disconnected this thing. Shit. Okay, we're back on. Okay, I believe you go here. Okay, we're back. If you build this, you will fry your fingers if you're not careful, because it's turned to DC. You're turning high frequency to DC, and that's what'll fry you, is the DC. See if we can get back to 500. Okay, oop. There it is. 2,200,000 hertz. 2.2 megahertz. Current. Oh yeah, that's good. So 19.50 times 545 volts is our output power in watts. Put the light bulb back up. I'm running out of tricks. I think I'm going to try and get a fan or something to run next. Should glow full intensity. Yeah, that's full intensity now. Yep, full intensity. I'll shut the lights off, let you get a good look. Full intensity. See, it's giving off plenty of light. As I move my hand along the transmitter, it'll get brighter or dimmer because I'm detuning it. Oh, it likes that. I should probably get a metal rod and insert it in the tube for even more tuning. We still got wireless. Fluorescent tube should kick on. There it is. Damn. Okay, still at full intensity. Yeah, I don't know what else to show other than the schematic, which is very simple. You can probably even see, you probably don't even really need a schematic. You can probably just build it on your own with how simple it is. I'll add a schematic soon, eventually. For the hell of it, I'll plug this light in again. Plug it in to 500 volts. And it won't even turn on. See if we can tune it. Yeah, I don't want to blow that light. I'm going to disconnect it. I had it running earlier in the video. That was shown. Get this thing tuned up. I'm going to try and get this thing max tuned on video too. Sweeping frequencies. Okay, there it is. 539 volts. We get 20 milliamps. Okay, voltage. 359. I hear a strange clicking noise in the meter. Yeah, because it's starting to kick out a lot of power. That's I don't want to blow a fuse in there. See? Full intensity. Alright, yeah, I think that's everything I wanted to show. Oh yeah, I'll plug the light bulb in normally to the signal generator and show that there's no way in hell it can run any light bulbs. So I'll take this guy. Here's the signal generator. And there's no way in hell you can run a light bulb off of just the signal generator. There's obviously a magnification going on. It goes through this system and it's pulling in energy from somewhere. Goes through the coil system, rectified to DC, stores in caps. And then the caps are what run the load. Yep, there it is. Alright, yeah, more to come. I don't know what the better design would be other than this. I mean, it's so simple, it's elegant, it's powerful. Maybe have multiple of them and combine their outputs. That's the next step, I think. This took me about 3 hours to build. I was kind of prepared to build it. I have all the tools, of course. It'll probably take someone else longer if they don't have the tools or if they have to wind it by hand. But yeah, more to come.